Howdy, AP PreCal. It is Miss Kosh. Every year I teach Polar. I get new insights, and this being the second year of trying to do AP PreCal, I have even more. And so I want to teach this the way I kind of taught it first period this morning. So we started. I'm using some of my notes, I'm using some from Mr. Passwater, and I'm relying heavily on Desmos, and also using things that I used to use before PreCal became AP. So that being said, here we go. What I wanted to do with this first one is I'm comparing the rectangular curve to the polar curve. So we know that cosine looks something like this. Okay, there's obviously more points that we're going to curve this out in a second, kind of round this out. If you're not familiar with graphing for cosine x, then go back and watch some of my old videos, because we're building on a pretty established foundation. Okay, what I also want is I'm going to need a few more coordinates, so I want to know when would this for cosine x equal to. It would equal to when cosine of x is equal to 1/2, which happens, cosine equals 1/2 at pi over 3. You may notice here that I have 1, 2, 3, 4, 5, and then the sixth one gets me to pi over 6. Gets me to pi. So you'll notice that each of these is pi over 6 apart. Okay, so this would be pi over 6. This would be 2 pi over 6, which is pi over 3. 3 pi over 6 is pi over 2. 4 pi over 6 is 2 pi over 3. That's a 3, pretend. And here comes 5 pi over 6, etc. Okay, so I intentionally set up this grid to be pi over 6 apart. So cosine will equal 1/2 at pi over 3, and then again at 5 pi over 3, and so forth. Okay, so at 1/2, a half, which means that if I look at 4 times cosine of pi over 3, this is going to be equal to 2. So at pi over 3, I have the point 2. That was what I was going for. We also equal, at 2 pi over 3, when I plug in 2 pi over 3, I get negative 2. And so that should be down here somewhere. And then I have symmetry in these graphs. Is that right? No, that would be the wrong point. It's this one here. And so I wanted to, usually I don't require my kids to graph this many points with just cosine, and pretend I can draw a nice, pretend I hit the points. I didn't. Okay. But I want to use enough coordinates to show you what it's going to look like when I graph. When I was doing this yesterday, I struggled to see what the angles were, even though they're labeled. So what I found helpful was to highlight the axes. So here we go. Now I can kind of measure out my angles a little bit better. So if you don't need to do that, congrats. Okay, so this point right here, in terms of r comma theta, this becomes, it has an r value, well, it has a theta value of 0, and it has an r value of 4. You may remember from before, in the coordinate system, x, y goes input, output, but in the polar system, r theta goes output, comma, input, which is confusing. I don't know why they do that. If anyone does, comment below. Okay, so I need the point 4, comma, 0 in polar, which means 0 for the theta, and 1, 2, 3, 4 for the radius. So here's that point. Okay, next I have at pi over 3, I have the point 2. So this point right here has a radius of 2 and a theta value of pi over 3. So pi over 3 is there. Here's a radius of 2. I think I'm putting the point in the correct spot. Okay, next we have pi over 2 has a radius, this one has a radius of 0, and it's got an angle of pi over 2, which puts me at the pole. So the origin in the polar world is called the pole. Then at 2 pi over 3, this point here, this at 2 pi over 3 has a radius now of negative 2, which means, this is a refresher from last class, if we come out here, instead of going this direction deeper into quadrant 2, we have to turn around and go negative 1, negative 2. And so that is the point there in quadrant 4. Coming back to this point, this has a radius of negative 4 and an angle, a theta, of pi. So pi would send me this way, but it has a negative radius, so now we are here. So we are looking at, I can't draw a circle very well. Okay, pretend I can draw a circle. That gives us a circle. And so in class, we then went on to talk about, well, what happens when I make this? We looked at the possibility when it was a negative 4 cosine theta. And then we looked at the possibility of what happens when it's a 4 sine theta. And then we looked at the possibility of what happens when it's a negative 4 sine theta. I want to do that by going to Desmos. So the cool thing, you can come up to this little tool, what is that, a wrench or something? On here, I can decide what sort of grid I want. And so our whole lives we've been in the Cartesian or the rectangular grid, but now we can switch that to be the polar grid. Okay, and I can come down here, and if I switch to ABC, I can say R, where did my R go? There it is. R equals, we looked at 4. Notice that's another thing to talk about. If I want a radius, if I want a circle centered around the pole, I can just tell you what the radius is. R equals 4. Or I could say R equals 6. Or I could say R equals 1.23. Or, anyway, that's silly. But I can do, and then it gives me a circle with that radius. Okay, we were looking at 4 cosine. If I hit ABC, you can notice over, do you see where that theta button is? And there it is. So R equals 4 cosine theta. If I make this negative, then it reflects over, it's the y-axis when we're in rectangular. It's the line theta equals pi over 2, or theta equals 3 pi over 2, but it's been reflected there. If I come back and I change this to, change the function to sine, oh, hang on, let's get rid of the negative first, just so we don't get confused. Why do I struggle with that? Okay, go away, there we go. Theta is there. Okay, so sine theta equals 0 is going to give me a circle that sits above we would say x-axis, or above the line theta equals 0. So it's passing through the pole but sitting above it. All right, likewise, if I put it in a negative, hopefully you know what's going to happen. There you go. All right, coming back here, we then in class, we graphed this one and started plotting these points just to do it by hand. Trying to decide if that's a good use of the time in the video. Well, okay, I changed the scale. I said this is 1 and this is 2, and then I came over here and I said this is 1 and this is 2 and this is 3, just so that we could have 0.5 represented on our graph. And so sine is here, 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 here. And then I want to see how can I get sine of what equals 1/2? Sine of pi over 6. So when x equals pi over 6, we're going to be at 1/2. So that's here, because remember how we said each line was pi over 6? So we're doing, and then we'd be at negative 1/2. We'll plug that back in. So it gives me a few more points to make my curve. Something like that. And so when I come over here, I now have an angle of 0 and a radius of 1. So here's that first point. They're at 1. Okay, whatever. The next one, I see I'm at a radius of pi over 6. Nope, an angle, a theta of pi over 6, and a radius of 3/2. So pi over 6, 3/2. So this would be like 1, 2, 3/2. I made each circle 1/2. Okay, and then I get to pi over 2 is 2. Pi over 2, 1, 2, 3, 4. So 4 rings out is actually 2. And then, where am I? I am at 5 pi over 6, 3/2. 5 pi over 6, 1, 2, 3. Do you see that we've got some symmetry here? Hopefully you do. And then at pi, I'm at 1. Then, where am I? This becomes 7 pi over 6. I'm at 1/2. So 7 pi over 6 is this one, and so we've come in here at 3 pi over 2. I'm back at the pole. And then at 11 pi over 6, I'm at 1/2. And this shape started here at 0, came around, pretend I can draw, comes underneath and comes up, and then comes back around this way. And this is what we call a cardioid. AP will not require you to know the name, but sometimes it helps to classify them in your head. So coming back to Desmos, nope, that's not what I wanted. I'm sorry. This is what I wanted. We had, what was it? I was just looking at 1 plus sine of theta. And there's that cardioid. Okay, we can also see, we have other functions where if this became a 2, it gives us this, I've heard this called a limacon with an inner loop. If I make that a 1 and make this a 2 out here, it gives us a limacon, like I think they call this a dimpled limacon. There are, yeah, so there's different things that we can do. And so then what I did is, we can practice by hand, and if you want to, you're welcome to do it. I just don't think it's the best use of our time. I created these Desmos things where it allows us to discover certain polar graphs. So here's that with the radius of 2. We talked about that already. And then I have this scenario where it's a sine theta, but if my a value changes, as my a value changes, the a value, you'll notice, well, that's not a good one, right here, it's giving me, this is 6.5. It doesn't, that a value becomes the diameter of the circle. Okay. Then we could see with cosine, it's going to be off to this side. So here, as that value changes, when it becomes negative, look, it reflected. Okay, so pause. Then on the next one, I have, this one is called a rose. And so I can change the size. Notice my petal's size, the length of each petal is based on that leading coefficient out front. And with this one, when I have, when it's sine equals 2 theta, it gives me 4 petals. Okay, let's look at the next one. Oh, stop. Then when I have 3, sine equals 3 theta, same idea, the petal length can change depending on that, and if it's a negative, then it reflected. Okay, and here is cosine of 2 theta. So notice, well, here, let's look at, pause. Okay, as this one's kind of, it's going to look weird when I change the, so when it's 3, we have 3 petals. When this is, I'm going to change it by integers. When it's 4, you may notice we have 8 petals. When it's 5, we have 5 petals. When it's 6, we have 12 petals. So anytime that number is even, we have twice as many petals as that value. Anytime it's odd, we have the exact number. So, oh, I was trying to tell it 7. There we go. That gives us 7 petals. So the next thing that I wanted my class to do is, well, I was trying to find a way to help you organize your thoughts. Okay, so you could use something like this, or you could, I had made this chart years ago. And so we look at this, okay, so one shape that we have are circles. Another shape is the limacon, which we have a limacon with the inner loop or a dimpled or a convex limacon. And so there's different scenarios that fall into place here. What I would suggest doing is playing with Desmos and finding a way to organize this in your brain. And if it makes sense to have, this chart filled out, more power to you. AP will not ask you to know the names, but it does help you stay organized. The cardioid is where you would have R equals, this number and this number are the same. So it could be something like that, or cosine. The Archimedes spiral is cool. However, it's not directly required for AP. They'll give you some weird equations and ask you some rate of change questions, but they wouldn't ask you to draw it by hand. Okay, here's the rose, and this is, if n is odd, there are n petals. If n is even, there are 2 n petals, and that's the same for, but the difference between sine and cosine, let's say I have f of theta is equal to sine of 2 theta, and then I have g of theta is equal to cosine of 2 theta. Both of these petals have both of these roses have petals with a length of 1, and then if I say f of 0, sine of 0 is 0. Over here, g of 0, cosine of, well, 2 times 0 is still 0, cosine of 0 is 1. So this one is going to have a petal that starts here, and then it moves into the pole, and kind of depends on how many petals it has as to how tight that curve is. Whereas this one would start here and then kind of come out this way next. Okay, let's see what else we need to say. Okay, now here are Mr. Passwater's notes. Actually, I could pull pull up this link. And this is now looking at those different, here's a cardioid. And as I change that value, it gets bigger or smaller or reflects. When it's negative, it's reflected over that axis. Okay, super. And then the cosine one would open to the side. This one, if the values are the same, it looks something like that, but it changes when one value becomes bigger or smaller than the other. Okay, so if I change this and then change that, that's how I end up getting those and inner loops and outer loops. And there's all sorts of details. The shortcut, I think, for PreCal is to plug in either plug in 0, plug in pi over 2, or plug in something that gives you something that's easy to work with. And let's see, what else do we need to say? I think the cosine one is a similar idea. Okay, coming back. I think I check the instructions or check the description down below. I'll put a link to these worksheets. Okay. Now, what I want to talk about, Mr. Passwater teaches it by plotting points. I find it easier to work off of the graph. It's just a little easier and not so many details to get bogged down into, but he has some great multiple choice. So let's talk about some of these, and then we'll call it a day. Oh, no, then we'll do something else. I forgot. Okay, on this one, we know this is a rose with 3 petals, and so, but notice all of these are taking that into consideration. So what I would probably do is maybe say, call this one f of theta. And so let's see, f of 0 would be, f of 0, sine of 0 is 0, that's 0. Okay, that doesn't really help, that doesn't eliminate anything for us. This one becomes, let's call this one g of theta. So g of 0 would be 0, 0 again. This one, FGH, let's call this one h of 0. 3 times 0 is 0. Cosine of 0 is 1 times 3 is 3. Notice this should have this point right here. So we can eliminate that immediately. But this one, okay, this j, let's call this j. J of 0 means 3 times 0 is 0. Cosine of 0 is 1. This would be negative 3. That means we should have 0, negative 3, which would be over here. We don't. There it goes. Not an option. So now we need to see what happens. Well, what I would do next is say, okay, let's try f of pi over 2 versus, is that a good choice? Sure, okay. And then g of pi over 2. It doesn't necessarily tell us how we got there or whatever, but okay, f of pi over 2 means 3 times sine of 3 pi over 2. Sine of 3 pi over 2 is negative 1 times 3 is negative 3. So instead of coming up here to go pi over 2, I turn around and I go there, and that's my point. That's a good sign. This one, sine of 3 pi over 2 is negative 1 times a negative 3 is a positive 3, and so that would have this point right here. That is not an option, and so I find A to be the correct answer. The next one, they've given us this with an inner loop, and so I can do a similar process. What I know, let's see, cosine of 0 is 1, so then 2 minus, so if this one, we'll do j again. I don't know why I started here. J of 0 gives us negative 2, and so that actually, that point does exist, so we can't eliminate that yet. But if I tried j of pi, then I have cosine of pi is negative 1 times negative 4 is positive 4, plus 2 is 6. That pi 6 would be way over here somewhere. Oh, no, on the edge of the circle. I didn't see my labels. And that's not an option, therefore that's gone. Okay, looking at the next one, h. h of 0, cosine of 0 is 1. That gives me a 6 when I plug everything in. I should have a point here. I do not. No good. Okay, now, so we've eliminated it down to these two. So let's see, we might just know that the positive opens up and, or, you know, kind of lives up and the negative goes down. But if we forgot, which we might, let's try, this is what we call G. We can call it whatever we want. Let's call it G of pi over 2. Okay, so sine of pi over 2 is 1. So 2 minus 4 is negative 2. So pi over 2 here, and we have a negative 2, and that's this value here, so we're fine. That may not be, let's see what happens when I do G of 3 pi over 2. Sine of 3 pi over 2 is -1 times a -4 is a +4 plus 2 is 6. And that point is right there. So far so good. Let's see what happens when we plug those same 2 points we had called the first one f. Sine of pi over 2 is 1. So this should give me 6. So pi over 2, 6 is not on my graph, so no good. This is the correct answer. Okay, these can be tricky. And so basically it tells you we've given you part of this graph and tell us where did it start and where did it stop. So what how might I think about this? It was a struggle in class today. Let me think. We know that this graph is going to go something like this if I graph it rectangularly, if that makes sense. So this is at pi over 2, it should be -3. So pi over 2, -3 seems to be this point right here. Well, so what did it do? We started at the pole, and then we went into, as I traveled from theta of 0, which is here, to a theta of pi over 2, I actually have negative values here. And so I'm not going to be in quadrant 1. This is not how I taught it in class today. Okay, you never know how you get inspired. And so they're going to be negative, so they won't be in quadrant 1. They're actually going to be in quadrant 3. That's not what I have. Okay, so I can eliminate that mess. And I know that I'm not trying, this piece of the curve is not going from 0 to pi over 2. Okay, pi over 2, back to pi, so from this little piece right here, this would be pi over 2, I don't know why I'm using yellow, that might be tricky to see. Pi over 2 to pi over here, all these values are negative, but they're getting less negative, or they're approaching 0 again. So if they had been in quadrant 2 where they belong, well, they're not, but they're negative, so they should be across the way, and they should be coming back closer to the pole. And so it appears to me, based on that we want to go from pi over 2 to pi. Okay, that is the correct answer, I'm pretty sure. But let's see what happens if we try the others. So if I go from, let's use that color. If I go from 0 to pi over 2, 0 to pi over 2, we just said that it's going to start at the pole, and instead of moving into quadrant 1, it's going to move in quadrant 3, and it's going to do something like that. Okay, no good. If I go from 0 to pi actually gets me this, that's a terrible circle, but it gets me the whole circle. No good. Pi to 2 pi would be this part of the curve, which would start me at 0, and then this would be this is quadrant 3 in the polar world, this is quadrant 4, and so their positive values in quadrant 3 look something like this, positive values in quadrant 4 look something like that, and so that's no good either. So there's B is our correct answer. Okay, I think he's got 2 more multiple choice. I know this is kind of a long video, but hang with me. This, yeah, the multiple choice is the trick on this polar stuff. Okay, so they've given us a piece of this graph. This is a rose, and so what I see is that it started here at theta equals 0, because when I plug in 0, f of 0 would be 3 times 0 is 0. Cosine of 0 is 1. 3 times 1 is 3, and that sure appears to be that point. They don't maybe they should have maybe told us that it lives between 0 and pi, but anyway, I think we're okay. So the next thing, well, okay, so what I want to know is, when did I get to the pole the first time? Well, I got to the pole the first time when 3 cosine of 3 theta was equal to 0. The first positive time, divide by 3, I have cosine of 3 theta equals 0. When does cosine equal 0? So we're thinking back to our unit circle. Cosine is the x. It's equal to 0 at pi over 2. There are infinitely many answers, but that's the first positive one, and that's what I want. And so I'm going to divide by 3 or multiply by 1/3, and that gives me pi over 6. So it looks to me like this is going from 0 to pi over 6. Is that an answer choice? It sure is. Now we can verify by coming back to Desmos. I think I want just the boring one. Here we go. What did we have? We had R. There it is. R equals 3. We had cosine. 3 cosine of 3. Go find theta. There it is. Okay. And so did you know, if you come over to this part, I don't know if you can see where I am. I'm over here. I can change where, actually, let's see. I zoomed in too much. What just happened? Dang it. Okay, there we go. Sorry. We're fine. Okay, I'm plugging this in again on purpose, and I'll show you why. R equals 3. I wish maybe there's a way for me to copy and paste on my iPad, but teach me if you know. That's not what I wanted. Theta. Okay, so here's those graphs. What I can do is I can say, well, graph this from 0. I think the answer is from 0 to pi over 6. And look, that was that's highlighted green. So that's the little piece. If I changed this to pi over 3 took me all the way to where it got to the end of that other petal. So you can see I can watch this travel around the rows by changing the values where it's defined. So, and you can turn this one off and then see, oh, look, there's just that little piece. Cool. Okay, I like to put this on your test and quiz, my little darlings, so be ready for that. Okay, let's see. The figure shows the graph. Okay, here, so it's another, it's the exact same curve. If the domain is restricted to pi over 3 to 2 pi over 3, the portion of the graph, okay, so we just were looking at this one. And so this started we were at 0. We got to pi over 6. Here is pi over 3 right now. We're here. And so then this becomes another pi over 6 gets me back to pi over 2. And so 2 pi over 3 is here. So this piece that I care about is, the piece that they're talking about is that. Okay, so let's see what they say. One of those pieces is the portion of the graph in quadrant 3 from C to D. I covered up, I think, well, yeah, I think D is there at the pole and C is over here. Which piece is the other one? It's going to be from D. Man, I can't see through all my mess. Go away. Okay. So basically what we wanted was this piece. It was from C to D and then from D to A. So quadrant 2 from D to A. Okay, another thing that I created when I first, before I started teaching AP, before it was a class, I saw a released question and I was like, oh, how am I going to teach that? So what I created was something like this, where I gave them the graph and I suggested that they color the different pieces on those intervals. And so this is a great way to practice the ideas. Now, they're obviously not going to ask you to color on the AP exam, but they will give you multiple choice like this. And so this could be a good practice for that. I will try and link all of these different, well, I'm not going to link Mr. Passwater's. I'll link my documents down below because they're mine and I can share them. But, all right, like, subscribe, comment, and go practice. The only way to learn all this math is to practice. Good luck.